Welcome back. Let's solve this problem. Now, one thing I need to tell you is that there's actually two equations for gravity, and that is your units in feet or is your units in meters. So in meters, it's going to be S of t equals negative 4.9 t squared plus v naught t plus s naught. So different coefficient for gravity because we have a different unit of measure. All right. So let us find, first of all, position, velocity, and acceleration as functions of time. All right, so of course we need to talk about the v naught and the s naught in our equation. So v naught, of course, is the initial velocity. Meters per second. All right, so initial velocity is 490 meters per second. Always check positive or negative. It's up, so it's positive. All right, let's find the S naught. All right, that is initial height. It's from the ground. All right, so our initial height is 0 meters. All right, it's on the ground. So that means the position equation, S of t, is going to equal negative 4.9 t squared plus 490 t, and there's no point in writing plus 0. The velocity, v of t, of course, is the derivative of position. So that's going to be negative 9.8 t plus 490. And a of t is the second derivative of position. So that's going to be negative 9.8. Right? So notice our position is a parabola. The velocity is a linear function, and acceleration is a constant function. Constant rate of change, or just a constant function. It is constantly 9.8 meters per second squared. Right, and let's talk about units here. So the units for position is meters. The units for velocity is meters per second. And the units for acceleration is meters per second squared. Right, B, how long will it take for the book to reach its maximum height? Right, we're looking for the vertex here. And we're looking specifically for the x-coordinate of the vertex. And that is for S of t. So B is, and just as a reminder, right, so that maximum is going to be that x-coordinate of the vertex is h, and h is negative b divided by 2a. That's actually how we're finding the x-coordinate of a vertex. Just a little reminder there. All right, so that would be negative 490, the x-coordinate for the coefficient on t, divided by, a of course is the coefficient on t squared, so that would be divided by 2 times negative 4.9. All right, so that's not going to be too hard to divide. All right, so if I divide 490 by 4.9, right, that would be 100, right? And so that's going to be 50. Make sure I'm not thinking crazy here. Yeah, 50. Sometimes it says 50 seconds. Right? The book reaches its maximum height. We should probably explain what some of these things are, right? Sometimes They get lax. Right, so and I just want to make sure it's clear for you as well. Right? Not much to explain on the equations, but we maybe could put in that the book reaches its maximum height at 50 seconds. Now we want to find out what's the maximum height. That would just be the y-coordinate for the vertex. For S of t. All right, so that means I'm going to just plug in 50. So S of 50 is negative 4.9 times 50 squared plus 490 times 50. And that's going to be so 2,500 times 4.9. That's negative, I'm going to write it in because I can't keep track of all these numbers in my head, equals negative 12250. Oops, that's a really sloppy 5. $490 times 50. And so that's going to equal 12,250. Right? And that makes perfect sense, right? That have that kind of symmetry there based on what we're plugging in. So 12,250 meters is the maximum height. And I have to say, if that student has got one powerful arm, maybe he should really think about a career in baseball with that arm that powerful that he can throw the book up 12,000 meters. Pretty impressive. And so, when does the book hit the ground? All right. So here we are looking for when S of t. Ooh, that's a little sloppy. S of t equals 0. And this is a pretty easy solve. So 0 equals negative 4.9 t squared plus 490t. Hey, let's factor out the greatest common factor. And that is negative 4.9, which would give us t squared plus, minus 100. All right, so it starts at the, so if we, oops. In my head, I knew what I was pulling out. I was pulling out negative 4.9t, and that would be t minus 100. All right, so we have two solutions here. T equals 0 seconds. Well, that makes perfect sense because the book starts at the ground. And then we have t equals 100 seconds. Right? And that's when the book hits the ground again. Right? And then finally, what velocity does the book hit the ground? Here all we have to do is plug in when the book hits the ground into the velocity equation. So we're looking for v of 100. And I'll just do it right up here. So that would be our equation for velocity. It's negative 9.8 times 100 plus 490. So that's going to be negative 490 meters per second. Right? Is the velocity when the book hits the ground. It's kind of interesting. Notice that we got the same velocity when you start to throw it up in the air as when it hits the ground. Right? And we have now solved this one. Right? So this one's a lot like all the other questions, except I had to mention the different equation when our units of measure is in meters. And actually, this is the second time I did the video, because the first time I forgot to change the equation. So thanks for watching, and bye for now.